We good? Okay, then thank you all for joining us for the 6th edition, actually, already of the Lakeside Talks, this winter edition. And first of all, I want to share some sad news with you. Today there will be only one talk because sadly the other talk they had to cancel. So we will only have one talk today. But I'm absolutely certain that Florian will make up for it and he will have an excellent talk which we all will enjoy. So with that said, there is one new edition which is over there, which is where you can put in your tickets so you can exit Lakeside Park for free. It's there. And also we took into account that there's only one talk today, so pizza will arrive earlier than usual, so after this talk, so no problems there. Yeah, with that said, I'm handing over to Florian, and the stage is yours.
All right, thank you. Yeah, hello, I'm Florian. I'm one of the maintainers of the Captain project. And actually, I want to start with a quick anecdote because last year I presented Captain version 1 to the audience, and as a silly little joke, I put Giovanni in an embarrassing situation where I made him promise that we eventually were going to do something with Kubernetes operators, right? And today we are going to talk about Kubernetes operators. So glad that worked out. Yeah, so the topic of today's talk is GitOps and the Captain Lifecycle Toolkit. So the Captain Lifecycle Toolkit is a new project under the umbrella of Captain, which by now is also a cloud-native computing foundation incubating project. So we reached that milestone last year. And yeah, today I want to talk about this new product that we're developing and how it can be used, especially in the context of GitOps. And let's get started. So first, some theory around GitOps. Why do we actually think that's a cool concept? GitOps, basically the idea here is that you have the entire configuration of your application in a declarative and versioned way in your GitOps repository. So everything that's related to your application's configuration lives there, and every change to the configuration can be easily traced back using the commit history. And so therefore, you have a good traceability for every configuration change. And then with GitOps, so that's usually used in combination with Kubernetes, you have things reconciled automatically. So the rough picture here is that your configuration is basically a set of YAML files that define your Kubernetes resources, such as deployment, services, load balancers, and whatnot. And in that repository, you configure these objects. And then the GitOps solution that you're using, for example, Flux or Argo CD, will continuously monitor your GitOps repository and detect every change that has been made there, and then automatically apply it to your cluster so that your application reflects the desired configuration that you want to have here. Yeah, as I said before, this way the GitOps repository becomes the single source of truth. So you don't have to look over multiple different tools in order to gather an overview of your application's configuration. And this makes it much more manageable. And at the end of the day, this concept is pretty much the natural way to deliver apps in Kubernetes, because in Kubernetes you have everything defined using YAML manifests where you describe your application's components. So that's the really cool parts of GitOps that we are really excited about. But of course, with each opportunity comes a set of challenges. And let's just quickly go over them. So for example, you would also always want to have a good overview of your current state of your infrastructure before you deploy anything, right? So if you envision our GitOps tool like Flux or Argo CD, monitoring the GitOps repository continuously and detecting a change, you wouldn't necessarily want your application to be automatically rolled out if, for example, your cluster currently has some open issues. So, for example, a node being unavailable or insufficient resources being there in order to not have your application deployment fail, right? Then within your application, you might have some dependencies to external services, right? So for example, you might have a dependency to Atlas DB running somewhere else externally. And so therefore, before deploying your application, you would like to maybe check the state of that external service to see whether that's up and running and will not cause any problems to when it comes to deploying your new version of your app. Then, since applications, especially microservice-based applications, become quite complex due to the high number of different components that are part of your application, you might want to have a good overview of your actual deployment process. So you want to trace back every component of your application, and if the overall application cannot be deployed, you want to be able to pinpoint the exact problem, what actually caused the application rollout to fail. And finally, after deploying, that's not the end of the story. You also might want to do some post-deployment checks. So for example, that could be executing a performance test on your rolled out application and then making sure that your service level objectives are met, for example, right? And yeah, so these are the challenges that we have identified here. And now I will talk about how we aim to solve this using the Captain Lifecycle Toolkit, okay? So let's just quickly go over the goals that we have set ourselves when developing the Lifecycle Toolkit. First and foremost, we want to have minimum configuration effort, right? So if users want to get started with our product, then it should be as easy as possible for them to really make use of it and to get started and then eventually build up upon that. So that was really one of our main goals here, to not make the configuration overly complex. Then, of course, we want to integrate with existing GitOps solutions. So we don't want to reinvent the wheel here, but we want to integrate with what's already there. So imagine tools like Flux and Argo CD, or even a Jenkins pipeline that just deploys your manifests of your GitOps repository. So here we want it to be as compatible as possible, right? And also what we aim to do is we wanted to be able to integrate with several other tools to, within our deployment process. So we wanted to, for example, enable to, after the pre-deployment evaluations, for example, to also trigger a task, for example, that sends a Slack message informing you that your deployment has proceeded, or for example, create a Jira issue if the evaluation failed, and whatnot. So that we really didn't want to limit your creativity here, right? So that's another goal. And finally, we want to give deep insights into your deployment process, because as I said earlier, having this many components within an application might be hard at times to figure out where the application deployment failed exactly. So we wanted to make it as easily as possible there to point down any problems. And finally, we want to be cloud native, and so we want to integrate with Kubernetes especially as much as possible. So that's where our operators come in, and our custom resources that we have implemented as part of this project. And basically we want to also enable the toolkit to be application aware, because right now in Kubernetes you have your services and your deployments and replica sets, but out of the box Kubernetes doesn't really provide a concept of applications being comprised of multiple deployments and multiple services. So we want to basically add a layer to that and be able to consolidate parts of an application that belong together and then make that traceable and visible via the toolkit. All right, and yeah, so let's start with the first big feature of the Lifecycle Toolkit. So we provide built-in observability. Conceptually, the Lifecycle Toolkit controls and orchestrates all your application deployments if you enable them to be orchestrated with the toolkit, of course. So we don't touch everything without asking. And this way, the toolkit can aggregate information that might be interesting to you, especially as a DevOps engineer. So here we provide several DORA metrics, like the mean time to deploy, then the change failure rate, then the deployment frequency, and the number of successful deployments, obviously. So, and therefore, as part of this project, we also provide a Grafana dashboard that you can import into your Grafana instance after you have installed the Lifecycle Toolkit, and then you will get this nice overview with these metrics, and also with the with OpenTelemetry traces, which you're going to see here. We'll also see this later in the demo. And using these traces, we aimed to make the deployment process traceable. So for each component of your application, you will then have a trace, and if something goes wrong there, you will be able to find this here easily. Yeah, screenshot is a little bit small, but here, for example, some step of the deployment process failed, and then using the event information that you will get here, you're going to be able to see exactly what went wrong here. And yeah, one other aspect is, since I already briefly touched upon ease of configuration, so we want to support existing application manifests pretty much out of the box, and that's why the Lifecycle Toolkit supports the Kubernetes recommended labels, like the Kubernetes.io component or part of and version fields. And based on these labels, we are able to, or the Lifecycle Toolkit is able to figure out which application a deployment, for example, belongs to, and is then able to aggregate parts of the same applications without you necessarily having to change your existing manifests. And one of the upcoming features of the Lifecycle Toolkit is the application auto-discovery, which will then further make this easier. All right, then we have the observability and traceability part covered. Now we want to talk about pre and post deployment tasks and evaluations. And if you look at the bigger picture here, At the left side, you have your GitOps tool like Flux or Argo CD, or just you as a user applying your application manifests using kubectl. Then that's being applied to the cluster. And then the lifecycle toolkit will orchestrate your deployment. So based on the application custom resources that you're able to define here, you can refer to pre-deployment tasks that should be executed before the actual workloads are being rolled out. And then the same you can also do for each individual workload. So here you can make sure that, for example, a dependency to an external database is checked before actually allowing a pod to be scheduled on your cluster. And then once that's done, then the pod belonging to the deployment or stateful set will be able to be scheduled on a node and be able to start it. And then yeah, so that would be a very, very simple example of that. So here, using our captain task definitions, we are able to let you define your own JavaScript-based functions, as you can see in this example here. So here you basically check the availability of an external service, and that task is then being executed before the deployment rollout. And then similarly, if once the deployment is being rolled out, you might want to evaluate certain service level objectives, and that's where our captain evaluation definitions come in. So within your workloads, you are also able to refer to those. And in this case, for example, we are using a Prometheus query. So Prometheus queries are supported out of the box in the lifecycle toolkit, and here we calculate, for example, the number of available CPUs, and based on this information we can then say that the evaluation is successful or not. Okay, so now I've talked a lot about the possible features, but now maybe let's have a quick look at how you would actually enable your application to be used with the lifecycle toolkit. And we aim to do that as easily as possible. So for example, if you have your deployment, you are able to enrich this deployment using our annotations that we provide. So you can say that your deployment named simple node frontend service is a captain workload with exactly that name. Alternatively, as I said before, you could also do this using the Kubernetes recommended label, which is the component label. So that would also then be have the same effect as setting the workload annotation here. Then you can say which version that is, and finally you can refer to a set of tasks that should be executed during the rollout of this deployment. So here we have a pre-task called notify that would, for example, send a message to Slack. Then a pre-evaluation step where you check for an error budget within your environment. And then in the post tasks, you send another notification and do some tests. And finally, in the post evaluation, you can then evaluate your SLOs that you get as a result from this test. And yeah, that's then actually how one of those captain task definitions would look like. So here we have multiple options. So this is the inline specification of the function where you just put the code directly into your custom resource. So this is quite handy for very, very simple tasks. But you could, for example, also refer to an existing TypeScript file living somewhere on GitHub by providing the URL for that. And then the captain task controller will execute what's there under this URL. Similarly with the captain evaluations, so we have seen this before. Here you can define your query and then the evaluation target that you want to reach here in order to pass the evaluation. And then finally, this is optional, but in order to consolidate all the different parts of an application into an application right now, you would also have to define a captain app where you refer to your individual workloads. So that's the thing you would right now have to do to consolidate all these services. But as I said, coming later in one of the next releases, we are going to do an auto application discovery feature to automatically detect workloads of the same application. All right, now I've shown you a lot of theory, but I think we also like to see some stuff in action, and that's why we are now going to deploy our Potato Head application. So this is a demo application that kind of showcases a simple microservice-based application structure. So we have several different deployments like the potato head, the entry service, the right arm, right leg, left legs, and so on. And all these different deployments form the potato head application. And what are we going to see now? So we are gonna apply. We're gonna apply our application manifests containing the configuration for our application together with some of the Captain Lifecycle Toolkit custom resources. After that, the application pre-deployment evaluation will be executed, where we check for the number of available CPUs in our cluster. Then once that is successful, we are going to deploy our individual workloads. And during that rollout of the workloads, this is going to be set up in a way where we first deploy the entry service of the potato, because if you look at the picture before, all the extremities need to be attached somewhere. So before rolling those out, we want to make sure that the entry service representing our potato corpus is actually available. So we don't want to proceed with the other services before that's the case. And that's what we're going to do using one of the Captain task definitions. And then finally, once everything is rolled out, we are aiming to get a message on Slack informing us that everything has worked out. And not a recap yet. Let's meet over there at my IDE. Mirror this place. Okay. Apologies, this is live. Let me just fix this. I think, yeah. Let me exit the presentation, maybe that helps. Maybe now. All right, now it seems to be working. Let me just make this a little bit bigger. Yeah, so now we are looking at our application manifests. Maybe the actual meat here is in the manifest file, where we have all of our deployments included. So we have the potato head entry and we have the potato head. So that's all basically Kubernetes deployments using either the Kubernetes part of or the Captain application labels, if I can find it. Yeah, so here in this demo we use a mix of the Kubernetes recommended labels and the Captain annotations just to make sure that those can be used together. And basically what we see here, for example, in one of our deployments we have our pre-deployment task, which is called check entry service, and maybe I can even find this task. So basically here we check that our entry service is actually available. So here in this case the code lives on GitHub. It's very complex. So basically here we just check for the URL that we call here to return something, and that's how we make sure that our entry service is available. Then one other interesting aspect is the pre-deployment evaluation. So here we again execute a Prometheus query, and then based on that we evaluate whether our target value is reached. So basically before deploying our application, in this case we want to ensure that we have at least 10 CPUs inside our cluster available. And then the application.yaml kind of bundles it all together. So here you define all your workloads that you want to have inside of your application and their versions. And yeah, finally, in the post-deployment step, we are going to send a Slack notification. Again, here the code is on GitHub. Yeah, this just sends a simple notification to the Slack API in order to inform you about your application deployment. Then, without further ado, let's make sure that Grafana is working. So let's make a new terminal. So now we are going to deploy our version 1. So as you can see here, we have two different versions. We're going to see how those differ in a moment, but first of all, let's try to deploy our version 1. Okay, so all the manifests are being applied. Now we are going to our Kubernetes lens. And here, and that's the nice thing about custom resources in Kubernetes, you basically get the API for those for free. So they will, without any further configuration, show up here in your IDE, in your Lens Explorer. And for example, here we are now able to see that we have our potato head application containing our complete application services and the correlating Captain app version. So the Captain app version is the instance of an application deployment rollout. And belonging to this application, we now have several workload instances, but it seems like they are all stuck. But fortunately, we have everything orchestrated and instrumented with our Captain Lifecycle Toolkit. So we can see, okay, we seemingly didn't pass progress past our app pre-deployment evaluation phase. Yeah, so the current status, the current phase is that we are in this evaluation phase. So maybe let's check out what's going on here. And oh my God, it failed after 10 retries. So let's just check what might be the reason for that. And for that, if I can find my browser, yeah, here we are now at Grafana. And I think I have to restart the port forwarding. Okay. So, of course, this is a live demo, but usually you will see the deployment traces here in this section. I'm just not quite sure why it's not here now. But of course, that's the rage of the demo gods, probably. So maybe I have to restart something. So this is a local cluster that tends to be a little bit, yeah, let's say, tends to have its own life sometimes. Hopefully we can fix it here. Okay. Yeah, in the meantime, I can show you how you would alternatively debug this. So we will go into our namespace where the application was attempted to be rolled out. And as we seen earlier, our evaluation failed. And the reason for that was if we expect the evaluation status was that it failed due to the minimum required number of CPUs not being available. So we have 5 CPUs in our cluster. We had a target of 10, and therefore the lifecycle toolkit blocked the application deployment from being rolled out. And if we, for example, look at the pods, those are stuck in the pending state because our scheduler won't allow those pods to be placed on a node due to the pre-evaluation checks having failed. And now, to tackle this, let's try to adjust our targets a little bit. So we are gonna deploy version 2, where we have adjusted our requirements a little bit. So now we only expect 1 CPU to be available. And now let's check what happens then. All right, so our application is being deployed. Let's go back to Lens. Now we should see a new instance of Captain application version. Exactly, so now we have version 0.1.1, which already is in the app deployment phase. So it seems like the Captain evaluation was successful. So we have reached our goals. And also the workload instances should be in progress. Yeah. So we have our potato head entry, which is already being deployed. So here it says workload deploy. And the other workloads are currently still in the workload pre-deploy tasks, and that's exactly because of our availability check that's being executed before the deployments. So you can see, so those were not scheduled before the potato head entry is running. And now I've talked long enough, so now all pods are in the running state, and we have successfully deployed our application. And now maybe I have the chance of redeeming myself and show you the traces. Okay. For some reason, they don't show up here. But as I said, this is live, but at least we see our DORA metrics. So we have 1 succeeded deployment and 1 failed. 1 is still going on. This should eventually go back down to 0. And so that's that. Also, we see our deployment times. So our attempt of deploying version 0.1.0 took 56 seconds because we failed early during our Captain evaluation, and our succeeding version took 361 seconds due to the wait for our entry service. And what we can also see, because I promised you a Slack notification, and how late is it now? 20. Do I have Wi-Fi? Okay, as you can see here, I tried the demo out earlier a couple of times, but now is the one time where apparently not everything goes as smooth as I've planned. But here we do some, and finally it showed up. So now our application deployment is successful, and we have our Slack bot notifying us of our successful deployment. Yeah, so that concludes the demo. And just to recap, what have we seen? We have now seen an application-aware deployment. So we were able to basically aggregate all our individual deployments into one single Captain application to get us some overview of the deployment process. We have included some external tools like Slack and Prometheus into our deployment process. That was honestly quite easy. So if you recall this TypeScript code that was used for sending the notification, it was not overly complex. And I think the configuration of the whole thing with just the Captain app being added to your whole application deployment made it quite easy to make use of the Lifecycle Toolkit for our demo application here. Yeah, getting in touch, of course, we are open source. So if you are interested and if you would like to see if you manage to get the traces of your application deployment, feel free to install the toolkit on your cluster yourself and try to play with our examples and tutorials that we provide here. We are always happy for receiving feedback and maybe even receiving community PR. So we are always open for suggestions and contributions and are more than willing to look at your contributions. And yeah, you can also add us on the Captain CNCF Slack. And now I will be happy to answer some questions if there are any.
Well, the obvious one is, do you have any idea why the traces could fail?
Because I was feeling risky and installed the latest master branch, or main branch, sorry, and fixed a bug regarding to traces earlier. So I might want to review my PR. Yeah. So recently we introduced a feature where you can set the open telemetry collector URL where the Lifecycle Toolkit operator sends all the traces to during runtime using a configuration custom resource that we introduced. And there we apparently have to fix a little hiccup there, because earlier the collector URL was set during the initialization, the startup of the operator, and couldn't be changed unless you adjusted the environment variable, and here we wanted to be able to change it without starting the pod.
You showed us the application-aware mode with this special file, which brings together all the workloads. What are the benefits if you define it like that? You said it's optional. Why is it a good idea to define this application-specific file?
Yeah, so it's actually not the only option, so it is optional. Alternatively, if you only have a very simple application consisting of one deployment, for example, this is what we refer to in our project as a single service application. That's the case where our operator will be able to automatically generate this Captain app custom resource for you. The benefit of that is it would have been the most apparent looking at the traces, because using this Captain app custom resource bundles all the services together and then really gives you a nice overview in a time series timeline based on OpenTelemetry spans, giving you the possibility to really trace back your individual deployments of your components of your application in a single nice overview.
Thank you. And I've seen that you stated the versions of the workloads also in this application file. And I think probably also in the deployments, right? So why is it necessary to have it in both places? Is just to make sure that the right versions are running of this whole application, or?
Exactly. So this is to make sure that the Captain application custom resource doesn't refer to any outdated version of the individual workloads and to match everything together correctly.
Then, Florian, thanks again for this lovely talk. Don't forget to stay in touch if you are further interested in Captain in general. I think you will stay here for further questions as well.
Absolutely.
And I will hand over you to the customary Lakeside Talks little gift that we have. Please enjoy. Even though it's winter now, you might want to use it in summer.
The time will come.
With that being said, thank you for joining. And there's a couple of things that I want to add. So the next iteration of the Lakeside Talks is in May, on the 11th of May. Again, a Thursday. And I would absolutely appreciate if you would send me a proposal for a talk. So we're still looking for talks. If you have something that you think is interesting, please let me know. You can either contact me via Meetup or directly at contact@lakeside-hackfest.com. And I'll be happy to host you next time, or somebody you know, if you have someone where you think that they do something that they just need to share. Would love to host that. Since we have a couple of new people, I point out the parking validator again. So if you have a parking card, just chug it in there. And if that, with that being said, I think we're good to have some pizza and some beers if you're up for that. So thank you very much for coming, and let's have some pizza.
I wanted to ask you a question, Flo.